Welcome to the Laney Photography Department's presentation on light properties. Understanding light's properties and how it behaves helps us to understand how to use the light we see and the light we may apply or modify for our imaging. You can't see light really unless you look directly at its source or see its reflection. Light always travels in a straight line, except at the very edge of our understanding of physics, when it's bent by a very powerful gravitational object like a black hole or a planet. Where the light's blocked by a solid object, we have shadow. Light can be reflected, absorbed, or transmitted. Here we see light can be reflected, and what you see is the angle of incidence, that is, from the direction off the right, is equal to the angle of reflection, just like playing pool and hitting your cushions. Here we have light being absorbed, where the sun is sending out white light, which contains all wavelengths, and the apple is absorbing all of it but the red, and so we see the apple is red. If this were a black object, all of the light would be absorbed and we would see black. Light can pass through an object, like glass, for example. In this case, we have water is the object, and it has what is called an index of refraction, a particular way that it bends the light to our perception. Light, both passing through an object and refracted in this image. This is a basic property of lenses. You can see the lens focusing effect right here, and then you can see in this dark area some of the light being blocked by the denser layers of glass. Light can be modified. It can be scattered, for example. Here we have the sun, which travels through about 100 miles worth of atmosphere. Moisture, dust particles, and the higher wavelengths of light are the first to get blocked, and they get scattered around. And a high wavelength of light is blue, and that's why the sky is blue. You also see a little bit of rainbowing here as the light's getting split up as well. Light can be diffused. Now here's a process that combines transmission and scattering. That is, the light enters the diffusion material and it bounces around in there and softens. Scatters. Light can be diffracted. Now this looks like light could be bent, but that's not what's happening. We have light coming from here and coming from here as well, and when it goes through the slit, sure, this stuff goes straight, but the stuff coming from here also travels this way and this way, much less so as indicated by the intensity of the bands. But that's diffracted light. And this is one of the things that cause different kinds of aberrations and limits to sharpness, actual sharpness, or perceived sharpness in your lens. Past a certain point, you start to get diffraction, and so your edges are no longer sharp. It behaves very much like water through a nozzle. That is, that water's under enormous pressure, and as soon as it gets out of that container, the molecules are bouncing off of each other and they just run away from each other and you get this spray. Thank you for your kind attention.